Did you know that a Western professor is exploring the planet Mars? Data from a NASA rover creeping across the red planet's surface is rewriting our understanding of Mars. And Melissa Rice, who is an assistant professor of geology right here at Western, is part of a nationwide team that actually gets to drive the rover Curiosity.
So we're really just starting to get the word out that there's a Martian here on campus operating robots 100 million miles away on Mars. I think of the term Martian as referring to anything that is of Mars. And I use myself in that definition. I am one who studies Mars, who spends most of my mental energy on Mars, and so I am a Martian. I work with a bunch of Martians. Our rover is certainly a Martian, and so the term Martian is something we use to describe anything having to do with Mars. A lot of people don't know that there is a Mars research program here at Western because it's really very new. I'm part of a group of 400 scientists in total who are giving input into what the rover should do. We write a list of commands telling the rover everything it's going to do for a whole day. Drive 2 meters in this direction, take a picture in that direction, take another picture in that direction, keep driving, reach out with the arm and drill into a rock. You know, these are the types of commands that we give a rover for a full day. And we send the rover those commands at the end of our day. So when the rover wakes up in its morning on Mars, it has a whole list of commands ready to go, and it will just step through each of those commands. And then the rover will send us its data that it's collected that day at the end of the day, so that when we wake up and we come into the office and we fire up our computers here on Earth, we have a bunch of new images and data ready to use to make the next day's plan. So it's a long process to design and build and test anything that's going to fly into space, let alone land on Mars. And so right now, we are just starting the building process for the Mars 2020 mission. That rover's mission will be to collect samples from the Martian surface. It will drill into rocks, it will collect sample cores, and it will store those on Mars, so that the next mission that goes to Mars can pick up those samples and bring them back to Earth. So this next rover, this is the one that can potentially, eventually, answer a lot of our big questions about whether there are biomarkers preserved on the Martian surface. I think it is very possible, maybe even likely, that Mars was the kind of place that could have supported life. And I think that's about as far as we can go right now. We know that Mars had water. We know that it had a lot of water. We know that there was a time when there was precipitation on Mars. We know that there was water that seems like it was good enough to drink. And that's the kind of water in the kind of conditions that we know that organisms here on Earth like to thrive in. So we're developing this picture of Mars as a place that very well could have supported life as we know it here on Earth. The big question now is whether life ever did get a foothold on Mars, whether it ever did develop independently on Mars from life here on Earth. And that's the big question, and that's really what the next rover missions and eventually human missions to Mars are really going to be searching for, is those evidence of what we call biomarkers, evidence for a fingerprint of life on Mars.
With competence grows confidence, and that they can then go into the STEM field with that level of competency and understanding and be eager participants.
What studies find is that that girls feel confident in their skills right up until about middle school, and then we have all these great high school opportunities for kids. At the high schools, they've got robotics.